Z-test is used for testing the difference of two means with large independent samples. What are the assumptions for the use of Z-tests of two means? The first assumption is that the samples from each population must be independent of each other. And then the second is that the populations from which the samples are taken must be normally distributed. In addition to this, the population standard deviations must be known, and also sample sizes must be sufficiently large. That is, they must be at least 30 or more. 30 or more. First sample size should be 30 or greater than 30, and the second sample size should be 30 or greater than 30. Now, without wasting much time, let's look at a case in point. In a study to determine whether significant difference exists in quantity of broilers consumed between rural and urban households per month, we have the following data sets. We're going to impute this in Microsoft Excel. Now you can see the first column is the serial number. The second column is the data for rural households. The third column is data for urban households. And it just repeats itself that way. Now we're going to enter these into Excel spreadsheet. Naturally, the data set you are seeing here should enter into two columns. So you will have the data for rural households on the first column and data for the urban household in the second column. So let's go straight to Microsoft Excel. And this is what we are going to be getting. If you are running Z-test, it is important to note that your sample sizes must be large. That's one of the major reasons why we're using Z-test. Now, we have it thus. Rural households have their data set in the first column, which you can see now. And the total sample for the rural households, it's 133. We have a label at the top here. Then the total sample size for urban household is 140, which you can see there. Now, to run a Z-test, the first thing you need to do is to analyze the descriptive statistics so that we can extract the standard deviation from that table. The major ingredients of your Z-tests are the mean values, the standard deviation values, the degree of freedom, and then you have your Z calculated and Z tabulated values. So for us to be able to do that, we'll go to data and then select data analysis. And this will bring out this will give us our dialog box. Scroll down to Z-test, which is the very last item in the data analysis toolkit. Now, but before you do that, remember I mentioned that we'll need to do a descriptive statistics. So before you run the Z-test, you need to run the descriptive. So just press letter D, and that gives you descriptive statistics. And then you click on the OK button. And then you have your dialog box for descriptive statistics. Now the input range where you have the data set include, remember we have again the information for rural households, which ranges from cell A1 to cell, the first range of cells contain 133 data. So that will be A1 to A133. And then for the urban households, it will range from B1 to B140 down there. So this is 140. Less the label will make it 140. So you have A1 to A133 and then B1 to B144. So that's what we're going to enter into the input range. We're going to pick the first cell, which is this A1, and the very last cell of the next column, which is B141, sorry. So here we're going to select A1 to B141. That's where you can see your data set appearing. Now, one thing you must remember in Microsoft Excel, the sign : The colon sign you can see here is what represents TO, to. So don't go to write TO. You are supposed to give us the symbol, colon symbol, or the colon sign. So what this depicts here is A1 to B141. Naturally, by default, Microsoft Excel groups the data set in columns, which naturally should be like that. Now, because we have labels, the labels for this data is rural and urban. So we're going to check the labels in first row. If there are no labels there, we don't need to do this. And then we select summary statistics. Summary statistics. So this is where we get the measures of central tendency. So you see your mean, your standard deviation, your variance, and so on and so forth. Now, the next thing is to select output range. Output range. This is where we want our data to appear. I would like my data to appear on this same sheet, in this same window. So I need it to appear, use J1 to M22. J1 to M22 and click OK. So if you look closely, you see your information for the descriptive statistics. The descriptive statistics, you can see the components. You have your mean, your standard deviation. Let me just drag this so we can see clearly. Drag this to a manageable extent. And we have to reduce this. Okay. Fine. So this, we need all of this information because by the time we're running the z-test, it will require us to provide these details. So that's why you need to do this first. Okay, this is good. Now, you now just scroll down a bit, scroll down to the bottom of that, maybe like two to three cells below the descriptive statistics. Now we want to run the z-test. So again, we'll go here to the data and then select data analysis. Then we'll type Z to give us z-test 2 sample for means. Then select OK. Now, you have the z-test 2 sample for means dialog box. What is the variable 1 range, which is the first column in your spreadsheet? That will now be A1 to A133. A1 to A133. Oh, sorry, A1 to A134. That's what appears here, but there are actually 133 samples. Then variable 2 range will be B1 to B141. Remember, there are 140 samples for the urban and 133 for the rural. But because we have a label on top of each of the data, is going to be an additional 1 cell. So instead of 133, you'll be having 134. But the sample size is 133. Now, because we have done this, our hypothesis stated in the null form says there is no significant difference in the consumption of broilers between rural and urban households. So this means that our hypothesized mean difference will be 0. So we'll put the value 0 there. Then we need the variable 1 variance. The variance for the first variable. Come down here to where you have your descriptive statistics. The sample variance, you can see here, for rural household is 2.865573, and that of the urban is 7.874409. So we're just going to impute that here. 2.865573, and the other one will be 7.874409. Now, because we have labels, you check the labels. If you do not have labels, you don't need to check. It's important you check when there is a label. Now, by default, we are using the 0.05 or 5% alpha level, and then our output range. You click on it. We want the output to come directly under the descriptive statistics. So just go check where you have your descriptive statistics. Okay, well, that won't work now. But I know we have to, just for you to know, just look at this. We have J, column J. And well, I just have to cancel this. So, okay. So if you scroll down, this is it. Look at it. So this is J. Down, you have, if you scroll down, you see your cursor on J18. So that means you're going to impute as your output range J18 to maybe M, anything beyond J anyway. So we'll go back to data analysis and select our Z test again. We'll enter. So our output range will be J18 to M22. Any value, any alphabet beyond J will do. So that's what we have as our Z test value. So these are the two set of information we have. We have the descriptive and we also have the Z test. Now, if you look closely, if you look very closely, we have our mean values here for each of the type of household, the rural and the urban. We have our standard deviation. These are the values that we'll need to extract and use later. Now, if you come to your Z tests, see we have our mean, we have our Z. This is the Z calculated value. You have here the p-value for the one tail and the z-critical for the one tail. You also have p-value for the one tail and z-critical for the two tail. Now let me explain this. We're going to be comparing our z calculated value. This is the z calculated value. The z calculated value is minus 6.65585. Now note one thing. When you are running data analysis in using Z test, ignore your result. In your result, always ignore the negative sign, please. Always ignore the negative sign and make good use of the absolute values. Now, this is the reason why you need to ignore that. If you see the mean value, remember that the Z test equation is actually mean 1 minus mean 2. So the first mean you can see is 17.5 and the second mean is 19.44 and so on and so forth. Obviously you get a negative sign. So it could also have been 19 on the left hand side and 17 on the right hand side. That could have given you a positive sign. So you do not report this as minus 6.65. Report it as 6.65. Now we're going to be comparing the Z calculated value with this. This is normally the Z tabulated value. The beauty of running Z test in Microsoft Excel is just this. It gives you the calculated value and also the critical or tabulated value. So you can look at it, you can see we have 6.6 against 1.96 approximately. Now, peradventure, you wish to use the critical p-value. This is the critical p-value. The critical p-value is 2.82 raised to power minus 11, which is actually 0.0000, so many zeros before you have about 11 zeros before you have 28. So that's obviously, it will be your p calculated value. There are two ways you can make your decision, either using the critical p value. Here, the rule of thumb is this. The rule of thumb. We'll either use the critical p or we use the calculated versus the tabulated value. So any of these two will do. Now, using the critical p value, the rule of thumb here is that if p is less than 0.05, what that suggests is we reject the null hypothesis. And if p is greater than 0.05, then we accept the null hypothesis. So that's it. Now, peradventure, you wish to use the calculated. The calculated versus the tabulated value. That's tabulated Z values. The rule now will be if calculated Z is less than tabulated, Z, we accept null hypothesis, and if calculated Z is greater than tabulated Z, we reject null hypothesis. So you decide as a researcher which of the two you prefer to use. Now let's look at the tables again. Let's look at the second table now. Now, if you want to use the calculated, this is calculated value and this is tabulated value. So for calculated versus tabulated, our values here, so Z calculated is equal to 6.655 or 56 approximately, and then our Z tabulated is equal to 1.96 approximately. So by default, your Z tabulated is normally 1.96. Now, using the calculated versus tabulated rule of thumb, you can see here our calculated value is 6.656, our tabulated is 1.96. Now, if the calculated Z is less than tabulated, we accept the null hypothesis. And if calculated Z is greater than tabulated, we reject. Now, in this case, our calculated Z is greater. So we're going to be applying this. Meaning we are rejecting the null hypothesis, that there is no significant difference in the quantity of broilers consumed between the rural and the urban households. That's just it. Now, peradventure, we wish to use the critical versus the critical P value. Sorry, we'll come here. This is our critical P. So we'll come here. Critical P. Yeah, critical P will now be critical P. So our P value here, let's just write the P value. Our P is 0.12345678910. Then 282. So this is what it is actually. If you count very well, you have with the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so we have 10 zeros after the decimal. So this is what 2.82 times 10 raised to the power minus 11 will give us. So now, obviously, you can see here, the rule of thumb says if P is greater than 0.05, accept the null hypothesis. But if P is less than 0.05, reject the null hypothesis. So obviously, P to be equal to 2 times 10 raised to the power minus 11 is far, far, far less than 0.05. So we're going to be rejecting. So either way, Whether you use the critical value or you use the calculated versus tabulated value, you're going to get the same decision. This is about the decision. So in the decision, you need to check the rule of thumb of either using the critical value, p-value, or the calculated versus tabulated value. I'll show you a simplified version of reporting what we have just done. I'll just take you here. This is it. So this is our table. This is our table. Now, the variables, we have variables for rural households, and then for urban households. The sample size for rural household is 133, as I explained before, and then the sample size for urban is 144. The mean values for each of the household is 17.586, approximately 18, and for urban household approximately 19. So in rural household they consumed 18 snails on the average, while urban households consume 19 snails on the average. Now, if you look at the standard deviations, which we also extracted from the descriptive statistics section of the z-test table, we have 1.69 and 2.80 respectively. Now, for the degree of freedom, the degree of freedom is normally denoted by N1 plus N2 minus 2, which you have here. N1 is 133, N2 is 140, and that gives us the difference between the two. Adding both of them together and subtracting 2 from it, following that formula, will give you 271. So our degree of freedom will be 271. And then this is our Z calculated value. Remember, you ignore the negative sign in making your explanation. In reporting your result, do not take into cognizance the negative sign. Ignore it. Use only the absolute values in your interpretation. Then our tabulated Z tabulated value, it should be tabulated, or just tab, that should do, will be to be 1.96. Now, since 6.65 is greater than 1.96, we are obviously going to reject the null hypothesis. So that's it. What this suggests is that there is significant difference. There is significant difference. So since the calculated Z value of 6.655 is greater than the tabulated Z value of 1.96, the null hypothesis is rejected. So that's it. And please always remember, since it's we found significant difference, always put this. It's always good to put this negative, the less than sign here, 0.05. Many persons confuse this when your remark is to reject the null hypothesis, suggesting that there is significant difference between the first variable and the other variable. This p should be less than 0.05. But if it is a situation where you accepted the null hypothesis, it will be the other way around. P will be greater than 0.05. So always put this here to guide people who may want to adapt your work. And that will be it. So this is just what we have done. We have looked at z-test, and we said it's used in testing the difference of two means that are independent. And we're looking at two large means, and large is expressed by the size of the samples, which should not be less than 30. So it must be 30 or more for each of the two independent samples. The first sample greater than 30, second sample must be greater than 30 or 30 on the dot. This is the condition under which z-test is used. It is very important to take note of this. So this is our table again. If you love watching this video, kindly subscribe to my YouTube channel. Do not forget to hit on the notification bell. In another video, we're going to be looking at t-tests we're going to be looking at analysis of failures. Thank you.